Hey fellow coder, in today's video we are diving into a fantastic optimization challenge, finding the top k frequent element in an array. But here is the twist. We'll achieve this without using a heap. Instead, we'll harness the power of the quick selection algorithm to efficiently zoom in on the key most frequent element. Let's get started. At first, I will explain this problem. This is 347 top k frequent element LeetCode problem. Have a description? Yep. Given an integer array, numbers, and an integer k, return k most frequent element. You may return the answer in any order. I have example 1. There 1 1 1 1 2 2 2 3 k 2. That is output is 1 and most two frequent element is 1 and 2. And example 2 is 1 and k is 1, so it obviously is only one output. Let's jump to code. Let's what's thought the type escape code is step by step populating the frequency map. We start by constructing a frequency map using map data structure. For each element in the input array number, we increment its frequently count in the map, preparing unique element. We exit the unique element from the frequency map and store them in the unique numbers array. Quick selection algorithm. Now comes the heart of our approach. The quick selection algorithm. We call the quick selection function passing in the unique number array, the left and right index, the desired k value, and the frequency map. Partitioning for quick selection. Within quick select, the partition function rearranges the element in the number array based on their frequency. Elements with higher frequencies are moved forward the beginning, finding top k element. The pivot index calculated by partition help us to decide whether we have found the top k frequency element or if we need to narrow our search. If pivot index match k-1, we return the first k element as the result. If it's less than k-1, we continue searching in the right half, and if it's greater, we search the left half. To sum it up, the solution demonstrates how to quick select algorithm can efficiently pinpoint the top k frequent element without using a heap. This approach capitalizes on frequency, count, and clever partitioning to narrow down the search space. By understanding and implementing quick select, you are adding a valuable tool to your coding arsenal. Remember to like and subscribe and hit that notification bell for more exciting coding adventure. Let's submit this code. That's a wrap for this video. We have explored a unique way to solve the top k frequent element challenge using the quick select algorithm. I hope you enjoy the journey of optimizing and learning. Keep coding, keep experimenting, and I will catch you in the next video. Happy coding.